Hi and welcome to yet another video, and in this video I want us to start a new topic, which is calculus. Calculus actually in most cases is divided into two sections, that is calculus 1 and calculus 2, and we are going to start with calculus 1, which is differentiation, and if time allows I'm also going to create some more videos for calculus 2. Calculus 1 is differentiation, and calculus 2 is integration. So calculus 1 is actually wide, so is calculus 2. So we are going to take some time in calculus 1 and then we move to calculus 2 if time allows. And in differentiation or calculus 1, we are going to cover various methods of differentiation. First of all, let me highlight the method of differentiation. We are going to start with differentiation by chain rule. Then we have product rule. We have quotient rule, and then we have differentiation of implicit functions, and then we have differentiation using parametric equations. These are the 5 methods that are usually examined in KNEC examinations, but actually for some time I have not been creating videos because there is some considerable changes taking place. Probably the next few years we may have KNEC examination completely phased out in TVET institutes. That's why I've actually not been creating more videos, especially to analyze the KNEC syllabus and also more mathematics videos on KNEC curriculum. But because I know there are some people who have refers who might need to clear their refers before KNEC completely get phased out, that's why I'm creating a few more videos. This topic are also in mechanical engineering, so those who have refers in mechanical and electrical are fully well taken care of. And also those who are in civil engineering and building, there's a number of topics which are in electrical and mechanical that also are in civil and building. So the point is, try as much as possible to clear with your refer. There's changes coming, we are not sure how long they'll take. Now I'll get back to business. After covering the various methods of differentiation, we'll cover applications of differentiation. Now before that, we can do higher order derivatives. Or how do you differentiate a function twice or thrice? Then we will do application of differentiation, that is when you are given a function of only one variable, then after this you do partial differentiation. In partial differentiation, we are going to use the method that we have learned to do complete differentiation to evaluate partial derivatives. Then after partial differentiation, we will cover applications of partial differentiation. Here we'll cover one application, how to find minimum and maximum points. We call them turning points or critical points. The minimum and maximum points. I will do the same here. We'll cover the turning points. We discuss about turning points or critical points or the stationary points. All those 3 terms refer to the same thing. We'll also Before this, we need to cover small changes. Small changes plus errors. Small changes plus errors. So that is it. As you can see, it's a bit lengthy, but what I'm sure of, whether we are moving to new curriculum or not, to the new CBET curriculum or in NEC, you still need calculus. That's why I've considered calculus as one of the topics I should make videos on. Let us start with the first method of differentiation. But before that, I expect by the time you are in your first year in electrical engineering and you're supposed to do calculus 1, or in your second year of mechanical engineering and you're supposed to do calculus 1, or you are in your second year of craft in electrical, or in building and civil. I'm not sure where I'm not sure where calculus appears, but whichever level you are, you should by then be able to differentiate simple functions. For example, if you are told y given y is equal to maybe 2x squared plus 3x plus 2, find dy dx. Now, of course, you know when you're differentiating this, you say it is 2 times 2 to be 4. Take the old power, which is 2, subtract 1. So the new power will be x power 1, which you simply say call x. Here it is power 1 times 3 is 3. Now we take the old power, we subtract 1, so it will be x power 0. But we know any number raised to power 0 is 1, so that x will disappear. Or it will become 1, which will be multiplied by 3 to get a 3. 2 is a constant. We know if you differentiate a constant, you get 0. Derivative of a constant is 0. So I believe by now you should be able to solve some simple problem like that. I'm going also to assume by now you should be able to use tables of common integrals. For example, you should be in a position to know the different derivative of cosine, maybe cosine x. If you differentiate that, you get negative sine x. Derivative of sine x is cosine of x. Derivative of exponential x is exponential x. Derivative of natural logarithm of x is 1 over x. There are more. Derivative of hyperbolic sine is hyperbolic cosine. So this is hyperbolic sine is hyperbolic cosine. Derivative of hyperbolic cosine is this is not equal sign, is hyperbolic sine of x, and so on. There are quite a number, but at least you should be able to use the S&P table, or at least you should be able to remember them off it. Let's start with the first method of differentiation, which is chain rule. Chain rule. I've checked from a number of past papers. Actually, I have a number of past papers. I've checked from a number of them. You don't get a question directly on chain rule. You don't get a question directly on chain rule, but actually, chain rule is applied in other methods. We are going just to discuss chain rule so that we can be able to apply it in other methods. Now, how can we differentiate simple functions using chain rule? Or actually, this method, chain rule, which type of function is used to differentiate? Or which functions can be differentiated using chain rule? You can say used to find derivatives of composite functions. Or what's a composite function? Or a composite function is a function of a function. Is a function of a function. For example, let's take sine 2x. Sine 2x. This is a composite function. Exponential 2x or 4x minus 1 is a composite function or is a function of a function. Natural logarithm of 2x, maybe 3x. This is a composite function. hyperbolic cosine of 3t is also a composite function. 2x minus 3 by 8 is also a composite function. All these are composite functions. Why are we calling them composite function or function of functions? Here, the first one, we have a function sine, the sine function. We have the sine function, but inside sine, we have another function, 2x. We have another function, 2x. So, this outer function, the sine function, we call it this outer function, and the inner and 2x, we call it the, so this is the outer function, this is the inner function. A composite function is a function that has another function inside it. So 2x is inside sine. The same case applies here. Exponential is an outer function because you can say exponential x or exponential u. So exponential is a function, but inside that exponential function, we have a linear function or linear equation for x minus 1. So the exponential forms the outer function, the 4x minus 1 forms the inner function. Same case applies here. This is the inner function. No. All of it, like this, whatever is inside by it is the inner function, not inner but outer function. Now whatever is inside, 2x minus 3, 2x minus 3 is the inner function. So the most important here when it comes to composite function is being able to identify the inner and the outer function. If you can be able to do that, then solving it will be very simple. Here for natural log itself in is the outer function and 3x is the inner function, because we know if you are told to multiply x times in x, okay, x times 3x, x times in 3x, you cannot say it is in 3x squared. That's wrong, because this 3x is inside natural, so it cannot be multiplied by this x. So the farthest you can go is that. You cannot go beyond that. Cos 3t is also a composite function, because we have the hyperbolic function, and hyperbolic cosine. Then you have the function 3t. So this is the outer function, and this is the inner function. 3t is the inner. So here we have outer function, and here you have the inner function. Having known that, it will be now very simple to differentiate composite functions. Let us start by getting a formula for differentiating a composite function or a function of a function. Given y is equal to sine 3x, find dy dx, or derivative of y with respect to x. This is pronounced derivative of y with respect to x, or simply dy dx. You are being told to differentiate the function y with respect to x. In this case, y is the dependent variable, x is the independent variable. Now, if that's the case, dy dx dy dx will be equal to derivative of outer function times derivative of inner function. Let, in this case, since you have y is equal to sine 3x, let u equal to 3x. Then in that case, y is equal to sine u. So u is our inner function, which is 3x, as we have elaborated earlier. This is the inner function. Inner function. Y equal to sine u is the outer function. So that getting dy dx becomes very easy. Getting dy dx is now, yes, we have said, derivative of the outer function. You can notice now y is a function of u. This is a dependent variable. This is the u now is the independent variable. Now on differentiating this, you say we are differentiating y with respect to u, or we are getting dy du. That's the derivative of the outer function times the derivative of the inner function. Now here you have u being a function of x, where u is the dependent variable and x is the independent variable. If we differentiate that, we can call that derivative of u with respect to x. So that dy dx is equal to dy du times du dx. Notice we can cancel out to get dy dx as we expected to do. Now we now go ahead and do the actual differentiation. Dy dx is equal to, what is dy du? If you are given y is equal to sine u and you are told to differentiate y with respect to u, of course we know when you differentiate the sine function, you get the cosine function, cosine of u. But we have said this one, we are not going to explain how we are getting it. By now you should at least have that knowledge. Times now the derivative of inner function, which is du dx. You take u, differentiate this with respect to x. This side will become du dx, which is what we have here. To differentiate 3x, you get, with respect to x now, you get 3. So now the actual derivative is 3 cosine of u. But what is u? U is 2x. So you have 3, not 2x but 3x. 3 cosine of 3x. 3 cosine of 3x. So that's how you approach that. But it's quite simple and very direct. It's only that for the first one I usually take a bit of time to explain, so that if you are to solve a different one, I'll skip a lot of explanation now that you already know what we mean, or certain terms what they mean. I'll try to be a bit quicker and visualize on the rest. Let me change rules. What about given y is equal to cosine of 4x, not 4x leader. Let us use 40 minus 1. Find dy dt. In this case, y is our dependent variable, t, probably time t is our independent variable. Let's get a solution. Here, you can say y is equal to cosine of 40 minus 1. Then we say that our inner function, let us call it u. U is equal to 40 minus 1. So that now y is cosine of u. To differentiate the original function y with respect to t, which is the dependent variable, it will be derivative of the outer function. Notice now y is a function of u. Derivative of outer function, which is dy or y, differentiated with respect to which variable now? Differentiated with respect to variable u, times u times, now we take u, we differentiate with respect to t. Or we take our inner function u, we differentiate with respect to the variable t. So we have du dt. So as we have said, this is our inner function. This is the outer function. So we simply have dy dt is derivative of outer function times the derivative of inner function. What are now those derivatives? If you differentiate y with respect to u, you get cosine of u, not cosine with it, but negative sine of u. If we differentiate u with respect to t, or du dt, on this side you get 4 times 4. Du dt is 4. So that finally you say this is negative this 4, let us bring it here, 4 sine of, but what is the value of u? U is, so we substitute back 4t minus 1. So that's how we go solving such a function. Now see something different. Given, do not write that properly. Given y, we don't really have to use y all the time. Given t is equal to exponential, or let it like this. Given x is equal to exponential 5t squared minus 1, find dx, derivative of x with respect to t. This time round, x is the dependent variable, t is the independent variable. Just as we have done previously, you can write it x is equal to exponential 5t squared minus 1. That we say that our inner function u equal to what you have here on the top, 5t squared minus 1. That's the inner function. Now the outer function y is equal to, not y reader, the outer function x is equal to exponential u. So x is the outer function, u is the inner function. To get the derivative dx dt, we know that now that here x is a function of u, we can differentiate x with respect to u to get x du, dx du, times u now is a function of t for our inner function. That derivative will be du dt. Notice as we said earlier, if you cancel out du with du, you get dx dt, which is what you want. So now what is derivative of x with respect to u? If you differentiate both sides with respect to u, the dx du, our dx du will be differentiated here with respect to u. If you differentiate exponential u, it will remain exponential u. You can check that in the S&P table. Derivative of exponential x will remain exponential x times, if you now take here, you differentiate with respect to t. Take 5t squared, you differentiate minus 1, differentiate with respect to t. As we have seen earlier, this one is already the basic, you should be able to do it by now. That will be 10t. Now we multiply the two, it will be 10 t exponential. What is the value of u? Substitute back 5t squared minus 5t squared minus 1. We can try another one. Given w is natural logarithm of 40, find the w or derivative of w with respect to t. Find the derivative of w with respect to t. Now, how do you go about this? So let us have our solution. We say w is equal to natural logarithm of t or in t. Or you can call it log base e. Log base e. So we say let our inner function u to be equal to 40. Then our outer function w to be equal to in u. We substitute 40 with u. Now go ahead and differentiate the two. Or say the w dt is equal to the derivative of outer function, which is, if we differentiate w with respect to u, you get dw du times u now is a function of t. If you differentiate u with respect to t, notice again, if you cancel out du, you get dw dt, which is what you want. And now, what is derivative of w with respect to u? What do you get when you differentiate in u? Natural logarithm of u. You get 1 over u. You get 1 over u. What do you get when you differentiate u, which is equal to 40? If you differentiate here, you will get that du dt will be equal to 4. Now finally you have 4 over u, which is equal to 4 over our u is 40, which is equal to 1 over t, which is equal to 1 over t. So that's how we go about that. When you are given a logarithmic function, this type of function we call it logarithmic. This type of function we call it exponential function, and we have previously worked with a trigonometric function, that is a sine or a cosine. We also have hyperbolic functions. For example, hyperbolic functions, we are given y is equal to cos 4 theta, find dy d theta. We will again say as our solution, let, what is our inner function this time round? It's 4 theta. Let u equal to 4 theta, so that y will be equal to cos u. So that if you now differentiate dy d theta, it will be derivative of the inner function, outer function, but whether you can reverse, it doesn't have any effect. You can say it is derivative of inner, you start with inner times outer. In multiplication, if you change the order of multiplication, it does not affect the result. For example, you know 2 times 3 is equal to 6. So if you alter 3 times 2, you change the order, 3 times 2, it should be equal to 6. We say multiplication is commutative. Changing the order when you are multiplying does not affect the result. So we can go ahead and say it is a derivative of inner function, which is derivative of u with respect to theta, or du d theta, times derivative of the outer function, which is derivative of y with respect to u, dy d du. Now this one, du d theta becomes, you differentiate u with respect to theta, or if you differentiate this side, it will be 4 theta. No, not 4 theta. If you differentiate 4 theta with respect to theta, it will be 4 times you differentiate the cos hyperbolic cosine or cos of u, you get the hyperbolic sine. You get the hyperbolic sine of u. So that now you substitute the value of u to be 4 hyperbolic sine of 4 theta. 4 hyperbolic sine of 4. Notice when you're dealing with the hyperbolic functions, there is no change in sign. For trigonometric, cosine will change to a negative sign. But for hyperbolic, the cos function will remain. When you differentiate, the result will still have a positive. The hyperbolic sign will still have a positive. Now let us move on and do the last one. What if we encounter algebraic functions? Like we are told, given w is equal to 4x minus 6 to the power 5. We are told find dw dx. The solution will be take w is equal to 4x minus 6 to the power 5. In a function, this one, what is inside here, let u or any other variable. It doesn't always have to be u. You can say maybe let t to be equal to 4x minus 6. It's good to learn to use different variables so that when the variable is changed, you don't get easily confused. Now w will be equal to t, which is 4x minus 6 to the power 5. This is the outer, inner function, this is the outer function. Now the derivative, after derivative dw dx will be equal outer differentiate with respect to t. Differentiate w with respect to t. It will be dw dt. If you differentiate t with respect to x, you get dt dx. Again, notice if you have to cancel here, it will be dt. You cancel with dt, it will be dw dx, which is what we have here. So that now dw dx is equal to, now you differentiate this, both sides. Now you differentiate w with respect to t. Notice, because both sides we are differentiating with respect to t, when you differentiate t to the power 5 with respect to t, it will be 5 t to the power 4 times, here if you differentiate with respect to x, dt dx, we differentiate with respect to x, on the other side it will be times 4. It will be times 4. So that now this becomes 20 t to the power 4. But what is t? 20 t is 4x minus 6 to the power 4. So that is it. That's how you solve such kind of problems. But remember, the most important thing here is understanding the method and the working. I've seen people complaining a lot about me making 1 or 2 mistakes in my working. It's not about trying to cram what I'm doing. It's about understanding the method so that if there is one mistake, you notice I've made a mistake, and because I'm doing several examples, if I make a mistake in one of the examples, you will be able to notice and move on. So it's possible I could make a mistake. If there is a mistake, just go ahead, understand the concept, don't worry about the mistakes. But I also try my best. If I notice a mistake and I can move it when editing my video, I remove the mistake. that is it. I believe I've not wasted your time in this video, and certainly not in the next video.